For those of you that have been following this series, you know I've been working on this 65265 board, and I had commented a while back that I did order up the secondary or audio-visual board to complement this. And I have received in that board and assembled it, and I have something that looks like this. So the idea here is that I have a connection that when I connect these boards together will allow the primary 265 microcontroller talk to and basically send over tasks to the secondary 265 microcontroller. And I'm doing that through the parallel interface bus, and I had a previous video where I got that up and running, that PIB basically. And so this board, this primary board, has been coming along nicely. I've been able to test quite a bit of functionality on it. I still need to get to my real-time clock and the SD card and some SPI functionality, but I'm not too worried about that. I think that's pretty minor. I know that this VIA works, and if the VIA works, the SPI is not that complicated, and I've done SPI with a VIA on a 65816 before, so that code's going to come over, I think, pretty quickly. But this board now, my goal with it is to leverage the VGA output. And then I also have a 1/8 inch jack for audio output. And that'll be like a line out. And with this board, I have the same power connectors, the same microcontroller, RAM, extended RAM, primary flash ROM, secondary flash ROM. I have a GAL 22V10 for decode, the same type of onboard piezoelectric speaker, and then my USB serial connection. But in addition to that, I have a spot for a versatile interface adapter that will control a pair of programmable sound generators. And I'll come to those in another video and see if I can get those to work. You know, step one will be to plug a VIA in, do some basic tests. Then step two is to control these. And these are set up to output through this line out over here. In addition to that, you can see I have a bunch of sockets up here, PLCC sockets. I have 3 for doing my, basically the logic for my VGA output. And this will just be a 320 by 240 by 1 byte of color. But then I have this series of sockets here for dual port static RAM, so that this microcontroller can write to that RAM simultaneously as the VGA is using it to pull out. Now I had done some testing. I was trying to use GAL 22V10s to actually generate my timing, and that I found did not work well at all. So I did go back to just plain old counters down here. So I have 6 different counters that will help me generate, along with these 3 GAL chips that will go in here, generate all the logic necessary, to decode, but then also to do my VGA and my sync signals, horizontal and vertical sync. And then this will be the RAM that supports that. And I've not put that in yet. I'm going to work my way up to that. Maybe in an upcoming video, I'll try to get the audio going. A later video, I'll try to get the VGA circuit going, which if the circuit I have in the schematic and obviously put into the PCB is accurate and works, it should be pretty easy to get this up and running, because all the logic I'm doing here I've done on a previous card, and it's really just getting it written to these PLCCs that I'm going to place into here. And again, all the stuff I've done on the audio in the past will come over pretty easily to this board. So let me fire these up. A couple of things. I'm going to plug in a USB down to this guy also. So I've got 2 USB connections, USB-C connections that are going over to my PC. I have power to my main board. I'm also going to use the same type of power connector and plug in a secondary connector here. So this switch will let me turn on power to both boards simultaneously. And for now, I'm going to leave them disconnected. And if I fire these up, I don't know, I'm going to actually bring over, I don't know if the speaker is going to pick it up or not, but I will set a little speaker here and see if it can pick up just the startup tones. It may or may not work. So let me turn that speaker on here, and then I'm going to power up my, systems. Okay, now I turned that speaker off if it even picked up those beeps, but I've got the post beeps that I'd implemented with this board down here. So when I first turn it on, it does a triple beep. This board, when I first turn it on, does a triple beep. I have a slight startup delay on this. I do not have a startup delay on here. So when I turn it on, I hear my startup beep here, and then I hear the startup beep here. And then this continues processing. This I put in a pause of a few seconds just to artificially delay it. And then I hear its completion post beep, and I hear that down here. And then what you'll see over here on my computer screen, I've got the two tare terms, one connected to the COM4, one connected to the COM6, basically these connections over to those COM4 and COM6. And you can see that as these booted, they wrote out initialization to the UART. So just basically both are running at 10 megahertz. One of them has the 1602 LCD and a keyboard input, plus I've added this TFT. This other one over here has the VGA output. It also has my audio output that's going to be controlled by these PSGs. So I'm going to go ahead and turn this off now. And as I get it connected, these will just basically slide together and lock in like that. So now I have a single board. And with this single board, this primary controller, when I have this up and running, I do not have this coded yet. But this 265 will be able to connect through this interface here, this connection, to this 265. So I'll be able to just simply submit a command, for example, clear the screen, or draw a rectangle, or write a string, or play a song. And this processor will then do all the work. This one can go back to doing whatever it wants to do next. And I will go ahead and turn this on. So both are powered off of the same box over here, and I am going to turn the speaker on again in the case that it actually picks up the tones on startup here. So both boot up, and it looks like I'm pulling about 1/2 amp at this point with these two just running here in their simple loop. And really they're doing very similar startups. So this one up here, obviously I took out all of the stuff for the keyboard and LCD and TFT over here. But I'm initializing this in a very similar fashion to this 265, the same type of post beeps. And that's all seeming to be working fine. And again, I'm running a 10 megahertz here and a 10 megahertz here for the F clock, basically, which will be my Phi 2 that the system's running off of. You're going to see these in future videos. I will probably be doing some work independently still. I think the work up here to get the video output and the audio, that can all be done with just this board. There's no reason I have to plug it into the primary board. But once I get that done, then from the primary, I want to connect it and basically send across some commands to play video out for the output, or play audio for that output. So I think this is pretty good progress for me, assuming, and there's still a pretty big assumption here that this video circuit will work for me, and I have higher confidence in the audio circuit over here. But minimally, I should have now my coprocessor that can do processing plus the audio support here. And if I am lucky, this VGA circuit will also work, and I'll have VGA output. And so running up the line, I've got my power, USB, PS2, another set of power, USB, then my 1/8 inch line out, and my VGA output. So stay tuned for more. I think next steps will be up here on this top board, trying to get my, probably my VGA. I'm probably most interested in that as a next step, and then I'll come to audio after that, I think.